Hey guys. All right, we're going to finish up our transformations notes today by filling in that last row that we left mostly blank. We're going to be taking a look at what happens to the coordinate points of a shape or a line when it goes through some sort of transformation. So we call that algebraic representation. But it's just really looking at what's going on with each x and y value. So we're going to zoom in here and start with translations. All right, so translations we know just kind of slide across a coordinate plane. It could go to the right, could go to the left, could go up, could go down, could go kind of any sequence of those ways. So the way that we write what happens to the coordinates is starting it out by saying xy turns into or becomes, we put an arrow there, x plus something or minus something, y plus or minus something. You know what? I wonder if there is, I'm going to see if I can find the plus or minus symbol on Cami. Okay, I found the plus or minus symbol, but it was too complicated, so we're just going to keep going. So we could have x plus a, y plus b. We could also be subtracting x, y becomes x minus a, y minus b. A and b are just integers. Okay, so in this example, we went 4 units right, so that affects our x value, where if we're moving right or left, that's our x axis, that's where our x axis goes. So this would be that xy would become x is moving 4 units to the right, so it's increasing 4 units because whenever we go to the right, we are going in the positive direction. So x plus 4, and then 2 units up would be up and down is y, so we're going with our y value, and since we're moving up, again, that's going to be plus 2. If we were moving left or down, that would be minus. So that's what we've got. That's how you write it in algebraic or represent it algebraically. Okay, for reflections, we've got where we can reflect it over the x-axis or the y-axis. Now, something different happens each time. So we're going to write it, start it out the same. If we reflect over the x-axis, x and y become, x stays the same, y becomes completely opposite. So this would actually have been the rule for this example because we reflected over the x-axis. So we can look at like point D is at 2, 2, and point D prime is, D is at negative 2, 2, and D prime is at negative 2, negative 2. So the one that changed there was our y value, and it just flipped signs or became opposite sign, right? It became negative there. If we flip over the y-axis, xy turns into x becomes completely opposite, but y will stay the same. Okay, so x will change sign, y will stay the same. So you can think of this, whichever axis you flip over or you reflect over, that's the value in your ordered pair that will stay the same. So for the x-axis reflection, x stays the same. For the y-axis reflection, y stays the same. The other one flips. Okay. We did this one together. And so let's finish up here. Whoops, can I move this? Nope. Okay. So scale factor, we said we multiply by our coordinate points, right? So x and y will turn into k, or scale factor times x, scale factor times y. whatever that is. So for this example, our scale factor was 2. So x and y became 2x. Well, became 2x 2y because we were multiplying by our scale factor of 2. Alrighty, so just familiarize yourselves with these rules. This is just, again, showing what's actually happening with the ordered pairs and the coordinate points and all that.